Soybean growers across the Midwest are always looking for ways to stay one step ahead, whether it's fighting pests, improving yields, or adapting to new market demands. At the University of Minnesota, breeders are working on long-term solutions that could shape the future of soybean farming for decades to come.
Breeding better soybeans in the U.S.?
In the front of this demo plot over here, we have varieties that were released back in the 1940s, 1950s.
Has come a long way.
These are the varieties that farmers grew, 70 or so years ago. You can see that they're falling down. They don't have very many pods on them. They're very tall and lanky, not very good agronomically.
Aaron Lorenz has called the University of Minnesota home for the past decade, and he says the soybeans of today are much more resilient.
There's been a lot of changes since the 1940s, but what do you think is the biggest benefit we have seen when it comes to breeding in that time?
That's a good question. I think a yield. On average, breeders have increased yield by about a half to a bushel per year. So right now, the varieties that farmers are growing on the landscape yield about 2.5 times more than the varieties that their predecessors grew back in the 1940s and 1950s.
Growing bigger bushels is often the end game for farmers, but in order to do that, breeders are also uncovering ways to protect farmers against the pests and pressures that rob yield. One of the biggest problems they're tackling, soybean cyst nematode, a pest that's evolving to overcome the defenses farmers have relied on for decades.
I would say that the things that continually come up would be, of course, soybean cyst nematode is number one. The main thing about soybean cyst nematode that's of concern to farmers is that the current resistance that most Minnesota farmers use comes from one single source that researchers discovered 40, 50 years ago, and has basically been in elite varieties for 40 or so years. So since it's been used so long and so often, there's been a resistance breakdown that occurs on the landscape out there. Basically, the soybean cyst nematodes on the landscape are evolving to overcome our current source of resistance.
So with soybean cyst nematode, do farmers typically know that they have resistance in their fields?
They may or may not. So the thing about soybean cyst nematode is that because the populations of nematodes out there in the landscape are evolving over time and changing and overcoming current sources of resistance, a farmer may plant a resistant variety thinking they have protection and resistance. But if the population in their field has changed to overcome that source of resistance, they may be losing yield and not even know it. So that's good. It's good to get a good soil test, rotate your sources of resistance to see if you get a yield benefit from a different source of resistance.
So growers can be losing yield and not know that it's actually from soybean cyst nematode sometimes.
That's right. Especially if they have resistance, the population in the field has overcome that resistance, they may not know it unless you do a soil test.
As a way to combat that resistance, Lorenz and his team are breeding with new sources of resistance, making sure the next generation of varieties is ready before today's tools stop working on farms.
We're working on, with some projects with Minnesota Soybean and the United Soybean Board, we're working on not just discovering those new sources of resistance. We are doing some of that in collaboration with a colleague, Senyu Chen in Waseca, Minnesota. We're doing some of that, but we're also mostly breeding with different sources of resistance to get those genes that we know have good resistance for new SCN populations on the landscape into elite varieties that farmers may want to grow.
But breeding isn't just about finding pests and boosting yield. The program is also working to meet the possibility of new soybean demand with renewable diesel.
We understand that there's a lot of potential future demand out there for renewable diesel, which is going to require a lot more oil. And we'd like to increase the oil content in the soybean up from like 22% up to maybe closer to 30% to make it more of a higher oil crop and make it more valuable from that standpoint.
That work started after Minnesota Soybean Growers Association came to the university with a challenge: find a way to breed soybeans to meet the growing need.
We work very closely with those growers groups to identify target traits that we should be working on, because they have their ears closer to the ground, they know what's out there, they can see the industry as a whole better than we can, and help direct us in terms of our research demand. So that's been a very fruitful collaboration.
From the possibility of a soybean that looks more like canola to other varieties that boast more oil than what soybean farmers are growing today, this public soybean breeding program spans across the state. And it's this research from field to farm that has a goal of meeting the demands of farmers and consumers down the road.
Well, what is it like to grow crops without soil? We take a look at that research from the University of Minnesota next.